Hello and welcome back. This is Enda Sullivan, and you are in CS1322. It is fall 2020, and this is lecture number 1. Today we're going to do a review of all of the information that you hopefully learned in CS 1321, possibly last semester or a couple of semesters ago. Everybody should have taken CS 1321 before they get to this class. That is a requirement, and you must have gotten a B or higher in that class in order for you to be able to take this. So today what we're going to do is we're going to do a review of some of the material from 1321, and we're just going to go back through some of the stuff that you know because, well, for some of you it may have been a while ago, and it's probably good to get a refresher. So without further ado, I am going to get started here. So the first thing we're going to talk about are variables, and variables, as you probably remember, are used to store information. Think of them as buckets. So you can have as many buckets as you want inside of your code. Each of the buckets will have a name, and into the bucket you can put one or perhaps more things depending on how complex the bucket is. The simplest things that you might want to put into a bucket are integers, which are just numbers that don't have a decimal point in them. So they can be stored in any of the first 4 that are listed here: byte, short, int, or long. The difference there is the maximum sizes that you can store inside of them. A byte only stores 8 bits, and as a result, it can only record from -127 to 127, whereas a long is 8 bits. So very specifically, this is 1 bit, 2 bits, 4 bits, and 8 bits. And if we just flip over to a quick Google, it will show you the actual sizes that it can record from. So we have -128 to 127, shorts, longs, or ints, and then longs. So for most of the time, you are going to store things in int. Why do we give you these options? Because in some circumstances, you may want to be very careful about how much memory that you're using. Honestly, for everything that we're going to do in this class, an int is always going to be fine. It is quite unlikely that you're going to be dealing with a number that's greater than 2 billion. So ints are probably fine. If you happen to need something bigger than 2 billion, then you're going to need a long. If you're storing something that's particularly short and you know it's going to be short, like you're just asking people for a menu to enter a number between 1 and 10, then you could store it in a byte and it will save a little bit of memory, and that's a good thing, sort of. I'm not sure I would lose sleep over it. All right. If you are storing a number that has a decimal point in it, then your choices are these two guys, which are going to be doubles and floats. A float is the smaller of the two of them. A double is double the size of a float. And it just records, it determines how much precision the number can store. And the precision is basically how many places after the decimal point will correctly be encoded in that number. Typically, for this class, we are probably just going to always use a double. Because again, it's memory. It's important when you're dealing with larger applications, and I'm being a little dismissive of that. If you are writing a big application that's going to be dealing with millions and millions of numbers, then yeah, that's a sizable difference in the size of the application, possibly in the runtime, possibly in the system requirements that you're going to need for somebody to be able to run that code. So in those circumstances, you might have to choose a float versus a double. But again, for this class, probably easier to just always deal with the double. And then the last of the basic types is a character, and that just stores a single character. The character is going to be wrapped in single quotes if it's a character. If you're dealing with a string, which is what we're going to talk about next, they're wrapped in double quotes, and that's important in both of the languages. As you remember, this class is going to be taught in 2 different languages simultaneously. We have the C# side of the world, and we have the Java side of the world. I mean, for me personally, when I do an example, I'm probably going to do it in Java because I'm working here on a Chromebook. And so running C# on here is not the simplest thing in the world. So as a result, you're going to see most of my examples in Java. If you happen to be in the C# version of the class, you're just going to translate those things. I mean, honestly, 95% of what we teach is going to be identical. And when it's not identical, I'm going to try and call it out. So talking about strings in C#, we have string, which is a lowercase string. In Java, you have string, which is an uppercase string because reasons. And then the final type that's mentioned on here is a Boolean, which in C# is BOOL, because we can't afford 8 or 7 characters. We can only afford 4, apparently. In Java, it is Boolean, which is going to have fully spelled out Boolean. Booleans store true and false. They're very useful if, again, you're asking a user just to say yes or no, true or false kind of things. You can store that in a Boolean. It takes up a lot less space than storing it in a string where you type out the word yes or something along those lines. All right, and hopefully as you remember, when you're declaring a variable, that's done with first you type the type of the variable and then the actual name of the variable. So for example, we have integer my num, and you will end every line with a semicolon. That's very important. All languages. You will see me forget to do that because reasons. You can also initialize it as you declare it, which means that you're setting a value in the variable as you declare it. So in this case, int my num is 42, double tax rate is 0.07, or float interest rate equals 0.065f. That f is important if you're dealing with floats because the default is to assume that it's a double if you put in a decimal point. So you have to call out that it's an f or you'll get a type mismatch. All right, so let's flip over to REPL, which, as we mentioned in the first class, is something that we're going to use just for debugging and demonstrating. It's very simple. You don't have to install anything. It just works in a browser, so that's super handy. I'm going to do most of my examples in here, which also means that they're available on my account. You should be able to go to repl.it /@endasullivan, which is my name, in case you forgot. And then in there, you're going to see the different examples that I have. And so this particular one that we're going to work on today is the silly guessing game. And I'm just going to start off from scratch, and we're going to edit one in here together just so that you can see me doing that. And if you're not familiar with this interface, it couldn't be simpler. You go in, you say that you want to run in Java. It gives you a blank window, or actually it gives you a window that has a hello world in it so that you have a nice place to start. And on the right-hand side, you have a little run window. And if you want to run it, you click that, it goes ahead and compiles it for you. And then it also outputs whatever output you're getting from the code. So in this case, after a moment, it should say hello world. It does sometimes take a moment because, well, you know, that's the way of the world. There it is, hello world, very exciting. All right, so let's go ahead and declare a variable here. And so what we're going to do is we're just going to set up an int, and that integer is going to be called answer. And we're going to set the answer for now to be 6. Okay, why are we doing this? Because, well, reasons, I said so. That just basically creates a variable, and the variable is set to the static value of 6. So we're going to run that. Absolutely nothing is going to change. It's simply going to still output hello world. I'm going to just change this code so that it says my answer is, and then if you want to put in a variable into your output, you do a plus sign and then the actual word that you want. So now when I run it, it's going to say my answer is 6. This is thoroughly gripping stuff, I know. It feels like you're compiling 5 million lines of code sometimes. There we go. My answer is 6. See, so worth the wait. All right, so that is how you set a variable in Java. It's the exact same in C. In C#. All right, so how do we write stuff to the screen? And that is going to be dependent on the language. If we are in C#, we're going to use console.write or console.writeLine. The difference between the two is that console.write does not put in a carriage return, which means it just writes the output. And then if you put another write, it'll write it immediately after it on the same line. If you do console.writeLine, it'll write the output that you ask for, and it will move the cursor back to the beginning of the next line. If you have ever seen somebody using an actual typewriter from back in the day, I'm not quite that old, but I'm not far from it, they're happily typing, and then they cha-ching, have to press some button to get back to the beginning of the line. That cha-ching action is the carriage return. It's basically moving to the beginning of the next line. Yeah, I don't know why that was important. All right, so if you're trying to read input from the console, so you're trying to get something back in from the user, then you're going to do console.readLine, and that gives you a string. So you have to declare a variable which is of type string. In this case, we're calling it A, and we're doing console.readLine. What you get out of that is a string, because That's what console.readline gives you. If what you mean for that to be is an integer, you're going to need to convert it to an integer. If you need it to be a double, you're going to convert it to a double. If you need it to be anything else, you're going to convert it to whatever it is. So there are various parse methods for that. int32.parse will convert it to a integer. Float.parse or double.parse will convert it over to floats and doubles respectively, obviously. So if you're in C#, that's how you do reading and writing from consoles. If you are in Java, then the syntax is slightly different. You're going to do system.out.print or system.out.println. And again, the difference between the two is whether you get the carriage return or not. That's how you put content out on the screen. Please note system is capitalized. And then if you're trying to read it in, the syntax is a bit goofy. You're going to need the Java object scanner. And you're going to do, in this case, you're going to declare a variable called scan, which is of type scanner. And you're going to initialize it with system.in, which is effectively the keyboard. You're telling it to take input directly from the standard input of the computer, which in all cases is going to be mapped to the keyboard unless you do something crazy. You can also put a file name in there if you're trying to read from a file, but that's a whole other day's work. Once you have initialized it, then you ask it to give you back the next line. Next line will return a string. And so in this case, we said string word equals scan.nextLine. And you can call that multiple times to get in different bits of the input. There are other things that you can import. So like, for example, if you're trying to read in something that is not a string, there are other methods for doing that. And we'll see one of those in just a moment. All right. So what we're going to do is we're going to go back over to Replit, which, by the way, I don't know how to pronounce that. I'm sorry if it's bothering you that I'm saying it differently every time. I'm going to say it differently every time because how do you pronounce R-E-P-L-I-T? I don't know. Replit? Repel it? Repelit? I don't know. Here we are. Replit or something. Okay, so what we're going to do is system.out.println. We already were printing out an answer. That's great. What I'm going to do is I'm going to ask the user for a guess. We're going to play a guessing game. It's going to be the most fun thing ever. All right, so we are in Java. So in order to read in some input, we are going to say scanner. I'm going to call it SC, and I'm going to say new scanner. And I'm going to pass it system.in. And we're going to put a semicolon. It would be nice if I actually told them what it is that I'm expecting them to do. So I'm going to do a, why are you being like that? All right, I'm going to do an output and just say system.out.println. Please enter your guess. Yay. All right. And then we're going to actually get in an integer. And the way that we're going to do that is we define an integer. I'm going to call it guess because it is their guess. And it is going to get next int from SC, which is my scanner object. And we need a semicolon. All right, so in the example on the slides, we were doing next line. In this case, we are doing next int. And the difference between the two of those is I'm reading in an int. The slide was reading in a string. So, yay. Okay, I'm just going to output what they did. System.out.println, you guessed, and then in order to put a variable in a print string like this, you're going to use the plus operator, which basically concatenates two things, and we are outputting their guess. All right, we're going to run this. We're going to figure out what I did wrong. I forgot a semicolon because I said I was going to forget semicolons constantly. So here we are. Did I get them everywhere else? No, I did not. I didn't get it here either. It's almost like it highlights it for you. There we go. And we chug and chug and chug. And scanner. Oh, yeah. If you're going to use scanner, you actually have to import that class. And that is import java.util.scanner. All right. Let's see what else I messed up. Good Lord. All right. sc.newInt cannot find symbol, and that is because okay, yeah, it's not new int, it's next int. Oy vey. Okay, here we go. Sorry about that, guys. It's also one of those things that you stare at it and it looks perfectly reasonable and you're debugging it at 3 o'clock in the morning going, why is this not working? Okay, so it says, please enter your guess. I type in 8 and it says, you guessed 8. Cool. Not a very useful game, but here we are. All right, so back over to the lecture slides. All right, going forward, we're mostly going to use the words print and read, and you're going to be on your own to remember the syntax in each of your languages. So in pseudocode output, we're just going to say print, what is your name, read, user input, name gets user input, and print hello plus name. As you can see, that's just shorthand of what we did. Generally, when you read input from the user, you have to remember that the users are idiots. Users are going to give you the wrong input. If you ask them for an integer, they're going to type in happy, happy fun sale, which is not really what you want them to type in. So you're normally going to have to check that what they gave you is a correct type and is the correct thing that you were expecting. If you say, please choose from the following menu, and you give them 3 options, inevitably somebody will type 7. Because users are idiots. So it's up to you to check all of those conditions and make sure that what they're giving you is the correct input. In this case, we're not going to worry about that for now. In a little bit later in the class, we're going to talk more specifically about how to do that correctly. Okay, so our user interaction basically boils down to we are printing onto the screen what it is that we want them to enter. We're reading in some information from them, and then we're writing that back out. And this is the example in C#, and this is the example in Java. They're basically what I just did in the other window, the Replit window. All right, so from now on, as I said, we're mostly going to use in the slides a simple print, which you're going to replace with either your console.write line if you're in C# or your system.out.print line if you're in Java, and a simple read, which we're going to use instead of scan next line or console.read line if you're in Java or C#. All right, so the next topic we're going to talk about are if statements. So now that we have read in some user input, the next question would be, what do we do with that input? And so it's common that you want to take some information that the user gave you, and then based on what they gave you, you may want to do one of multiple different things. So there are a few choices that you can do with an if statement. You can have a very simple if statement that says if, and then you will have some kind of condition. The condition can be either true or false. So in this example, we're asking them to enter an age. If the age is less than 18, then we're printing out you can't vote or drink. This must evaluate to true or false. So the content that's between the parentheses must be a Boolean. So you're going to do greater than, less than, equal to, or string compares, or did a function successfully return, or a method successfully return. Those kinds of things. If there is a single statement, then there's no need for curly braces, and this is language specific. If there is more than one statement, then you're going to have to put curly braces around all of the code that you want to execute when that condition is true. If statements can also have else ifs. So these are evaluated if the first if block does not succeed, it goes on and tries the next if, which in this case is the else if. So if the age is less than 18, then it prints this and then it goes to the end if. If the age is not less than 18, so if it's any number greater than 18, this is false. It will skip over this code and it will go on and evaluate the next else if, which says if the age is less than 21. If that's true, then it will output this content. If that's not true, it moves on and sees if there's another else if. There can be an unlimited number of else ifs. So you could say if their age is greater than 18, do this one thing. If it's greater than 16, do this other thing. If it's greater than 14, do this other thing. If it's greater than 12, do this other thing, and so on and so forth. So you can have as many else ifs as you need. And then at the end of an if statement, you can always put in an else, which is a catch-all that happens if nothing else happened. So if all of the other conditions at the beginning, the ifs and the else ifs, if they all failed, then you get to the else. And then finally, we have the end if, which tells you that we're done with this block of code. If we look at that in C# and Java, they are both identical. There is no difference in syntax between the two. So we're reading in how old are you, and reading that into a variable called age. And then this code looks pretty much like the pseudocode. The only thing that changed here really is the lack of an end if and the way that we read in the code. All right, so let's do that over in the REPL window. So what we're going to do is we're going to check and see if what they gave me is the correct answer in our very exciting guessing game. So we're simply going to say if, and the variable that we read in their guess was, the variable into which we read their guess, we called guess. So if guess is equal to answer, then we're going to say, yay. You guessed correctly. Yay. All right. So we'll go ahead and run this. It's simply going to ask. It's also giving you the answer up front, which is probably not very helpful. But we're going to guess it's 5 because we're not very smart. And it says you guessed 5. We're going to run it again. And this time we're going to guess the correct answer, which is 6. You note that in that first run, it did not output you guessed correctly because I did not. You guessed 6, and it says you guessed correctly. So the if statement only fires if this block of code is valid. I'm going to take out the fact that it's telling you the answer up front because that kind of takes the fun out of the game, really, doesn't it? All right. So let's use an else if here. So perhaps we might want to see and tell the user whether they were too low or too high. So let's say if this is going to be an else if the guess is less than the answer, perhaps we might want to say system.out.println you guessed too low. And while we're at it, let's go ahead and tell them if they're too high as well. So we're going to do another else if guess is greater than answer. In that case, we're going to you guessed too high. All right, and then finally, for any other answer, if they were not correct, and they were not too low, and they were not too high, then, well, what would that be? So let's think about that for a moment. If they got the answer correct, then the first block of code will happen. If they got the answer, if they gave an answer that was too low, then the second block of code will happen. And if they give an answer that's too high, then the third block of code will happen. So what's the other condition? They're either right, they're too low, or they're too high. There really is no other condition. So this else is never actually going to make any sense in this case because we've covered all the possibilities already up above. Either they are exactly equal, it is less than, or it is greater than. There really is no other circumstance. So how did we get here? The answer is we never will. There is no circumstance under which you will ever get there. All right, so we're going to run this again. Make sure I didn't do anything silly. I did. I missed a semicolon. I can tell before it gets there. All right, try that again. All right, and while it's compiling, I'll just mention that there's 2 semicolons. While it's compiling, I'll mention that I put curly braces around each of those system.out.printlns. Honestly, it's just good to get in the habit of putting the curly braces there so that you don't have to decide whether they're necessary or not. Just always put curly braces around your ifs and else ifs, around the code that's being executed. It is syntactically correct and equivalent to remove them in this case because I'm only doing one block of code for each of these options. If between the else if and the next else if there is only one statement, then it is fine to leave the curly braces out. If there is more than one statement, you must put the curly braces in. It is always fine to put the curly braces in, which is why I said just get in the habit of putting the curly braces in all the time. All right, so please enter your guess. I'm going to guess 5, and it says you guessed too low. All right, well, that sounds good because we know that the answer is 6 and 5 is too low. All right, we're going to run it again. It's going to ask me for a guess. I'm going to say 9 this time. It says you guessed too high. And we're going to run it one more time. This time we're going to get it right. The right answer was 6 in case you've forgotten because that's stored up here in this variable. So we say 6 and it says you guessed correctly. So that's basically if statements. They are a way for you to do one thing depending on some other thing. So if the evaluation of the if statement is true, it will do the block of code that's directly below it. If it is not true, it will move on. If there are else ifs, it will try them. If there is an else, it will eventually do the else if the if was not true. Once it does any one of these, however, it does continue on after the last curly brace. So no matter what happens with this if statement, the next block of code that would happen would be down here, no matter what. All right, so that is conditionals and if statements. And again, this mentions the same thing about the curly braces that I just mentioned as well. All right, in the next video, we're going to talk about declaring methods and getting return values from the methods. So I will see you there.